So we're moving on to one of the more important lessons of this entire year, and that's how to figure out how to approach a problem that's a word problem, and something where it isn't as clear and obvious what the method is of solving. You've got to actually come up with a problem-solving plan. And you've got to go ahead, and the very first thing you've got to do is read and understand the problem. Not just read it, but you've got to understand it as well. Then you've got to plan how to solve it and do it and check and see if your answer makes sense. So, quickly checking this over and thinking to ourselves, well, two examples here. Find two whole numbers whose product is 147 and whose quotient is 3. Okay, so we've got some numbers here, this here, and this here. But we've got a couple of really important clues here. Product. Remember, that means multiplication. Quotient. That means division. So we've got two numbers here, and their multiplication number is that, and their division number is that. And so we try out a couple of things here, and we think to ourselves, well, this number's pretty big, so let's try something that we know would work. Well, let's try 50 times 3. Well, that's not going to work. That's 150. 150. So that does not work. We haven't gotten there yet. So let's try 50. We can go ahead and say, well, that's 3 less, so it's got to be 49 times 3. And we see that the product works, but now we've got to check and see if the quotient works. Does 49 divided by 3, is that equal to 3? No. So we know we somehow have to go ahead and switch this number around. And I know the only two numbers that divide evenly into 49 are 7 and 7. So the only way I can change this problem around is by going ahead and saying 7 and keep it so it's at 147 being the product. 7 times 21. 7 times 21 is still going to be 147. And now 21 divided by 7, that is going to be equal to 3. So we got our answer. It makes sense. And so this is going to be our answer, or at least, well, 7 and 21 are going to be our answers. Now here, another problem. In one school, 65 students speak Spanish and 49 speak Japanese. If 80 students speak either Spanish or Japanese, how many students speak both Spanish and Japanese? Okay, long description here of the problem, but what we're being asked to do is how many students speak both of these languages. We know this amount speak Spanish. We know this amount speak Japanese. And we know that this amount speak either one or the other. But if we look at this number here, we got, think about it, we got 65 students that speak Spanish. We've got 49 that speak Japanese. And feel free to write this stuff out as much as you need to. And then we've got 80 that speak either. So we know, well, hey, that number's bigger than 80. If we add that number to that number, we've got a number that's bigger than 80. So let's add those up and see. So 65 plus 49, that's going to lead us to 14. So 114. Okay, wait a second here. 114 speak this or this. If 80 speak either, so that means they speak only one of them. How many speak? Now the problem is, how many speak both? We know this amount speak that. We know this amount. 80 speak only one of them. So if 80 speak only Japanese or only Spanish, and we know that there's 114 students here apparently because they, or at least that speak either of them, because we just added up this and this. And all we do is we take 114, that's the amount of students that we know speak either, and we subtract 80 from it, because, well, hey, this is the amount that speak only one. And so 8 minus 1, or 1 minus 8 doesn't work, so we borrow from here again. 11 minus 8, that's going to be 3. So 34. So 34 speak both. And does that make sense? 34 would speak both of those languages? Sure it does, because then we go and add a 34, we got a 34 plus 80, and we got 114. And that seems pretty reasonable